Hey guys, in this video lesson, we're going to talk about shooting things horizontally in two-dimensional motion. Okay, so to start this off, we want to have a little bit of a thought problem. If we had two identical bullets at the same height above the ground, they're released at the exact same time. One bullet is dropped, while the other one is shot horizontally. Which one hits the ground first? Okay. Now, assuming everything else is equal, and we do that, let's take a look to see what happens. To see this, we are going to use a little video from Mythbusters.
All right, you ready to do this for real?
I think we'll hit it on the first shot.
Really?
Oh, yeah.
You never make predictions. That's awesome.
Bullet dropped versus fired. In 3, 2, 1.
But from 360 feet away, the boys can't see exactly where the fired bullet landed.
Let's go see where it hit.
So Adam takes a one-wheeled ride down the room to check out the drop zone.
Wow.
And the results are simply ripping.
Can't get much closer than that. Ugh. I can't wait to see the high speed. So, dude, this bullet carved a streak right under the drop zone. I think this might be the shot we've been looking for.
In real time, it's impossible to tell what happened until Adam analyzes the high speed and crunches the numbers.
3677 minus 3915 equals 238 divided by 6. Dude, the difference is 39.6 milliseconds.
Which means it's less than the human eye can make out.
Okay, so the difference they found there was in the millisecond range, which is by far in the range of the error that they were setting up with the gun and all the stuff that they were doing. So essentially what that means is as we drop something, if we just drop it or launch it horizontally, as long as we're launching it horizontally, they fall at the same rate, which means they hit the ground at the same time. Okay. Now, when we deal with projectiles in general, there's some things that we have to be able to kind of make sure we understand in terms of some terminology and things that we're working with. So the first thing is, what is a projectile? Okay. Well, projectiles are objects that are launched into the air. Okay. They are affected by gravity, but they don't propel themselves, and that's kind of the key point here. We're not talking about rockets or airplanes or anything that has propulsion to it. Okay. We're looking at things that do not have propulsion, so like an arrow, a bullet, a ball, something like that flies through the air. We're also not looking at gliders because gliders are using a lot of air resistance and lift with their wings. So we're looking more at things that just fall through the air naturally. Okay. As they fall, we're looking at things and we give them what we call as a trajectory. Basically, it's the pathway that they follow. Okay. So when we talk about the trajectory of an object, we're looking at what's its path. It is parabolic, as we take a look at that when we launch things two-dimensionally. So we're always thinking along the lines of parabolas as we see things moving and falling as we move through space. Okay. Now that we've outlined this idea of projectiles, we should go back to unit number 1. In unit number 1, we talked about free fall, and we talked about how when you let go of something, it falls straight down, or you could throw it straight up, and we had some parameters behind that. Those same parameters hold true now. The only difference in this unit is instead of dropping it to go straight down or throwing it straight up, is we're gonna throw it with some horizontal speed also. Okay, so we just need to combine horizontal and vertical. So again, our free fall is the same. The nice thing in this unit or in this thing is that the variables are identical. So we have no new variables that we're dealing with that come from one-dimensional motion. However, we do want to be very specific about what's considered the horizontal, which is we're going to call X, and the vertical, which we're going to call Y. So in terms of our labels here, or our units or our variables, we're going to have a change in X, or horizontal displacement. We're going to have a change in Y, which is our vertical. Time is independent of our X or Y. So notice how there's no Y or X here because time doesn't matter if you're moving the X direction or the Y direction. Time is independent. We do want to talk about the velocity in the X direction. Okay. Notice here there's no VXI. So there's no initial X and there's no final X. And the reason why that is because the velocity in the horizontal direction does not change. So as long as we exclude air resistance, whatever you shoot or throw something in the x direction, it'll move at that same speed the entire time it's in the air until it hits the ground. We do have a change in our y velocities though, because gravity is affecting it and gravity is pulling it down. So we have this initial y velocity and a final y velocity like we had before. Our acceleration of gravity is the same again, our negative 9.81 meters per second squared. Okay. Then that brings us to components. So if you have both an x and y direction, we call those components of motion. So you have an x component and you have a y component. Okay? The actual projectile motion is a combination of both of these motions. Okay? Again, not any different than free fall, but now we have a horizontal part we need to deal with. Okay? So be aware that when we ask you for which component, that means we're asking for a specific part of this process. So either the x direction or the y direction. And then most of our practice problems that we're going to do, we're actually going to break it down into either the x direction or the y direction and solve things in both x and y values. Okay? We're going to stop the video here. In our next video, we're going to get into the actual equations for this. Thank you.